Good morning, Rama Shashakal, what I feel connected with. So this is our third lecture on trigonometry identities. Hope the previous two lecture helped you. Okay, now we'll do some harder question. Okay, in very first lecture we have done some basic questions. In next lecture we have done some more harder, and now we're gonna some level up the questions. And so start without delaying. The very first question you have to encounter, that is question number first of eighth question, and which is you can also see on your screen. This is 1 plus cot theta minus cosec theta multiplied by 1 plus tan theta plus sec theta, and you have to prove this as 2. Okay, now the very first thing you have to do is notice the question and try to think it. So there are cot and cosec, so these are not basic trigonometry ratio. First of all, we'll convert this trigonometry ratio in sine and cos. So let's start. So it will become 1. Okay, by taking left hand side, this is 1 upon 1. I can write it down. Cot theta is cos theta upon sine theta. Cosec theta is 1 upon sine theta. Similarly, we have 1 plus tan theta. Tan theta is sine theta upon cos theta, plus sec theta is 1 upon cos theta. Okay, now you can clearly see here we will take LCM as sine theta. If I divide sine theta by 1, it will be sine theta. Sine theta multiplied by sine theta 1, that will be sine theta, plus sine will be divided by sine theta, that will be 1, and 1 will be multiplied by cos theta, it will be cos theta. Okay, and here we will have minus 1. Similarly, we will solve this and it will become cos theta plus sine theta and plus 1. Okay, and now can you observe anything special in this one and this one? You can clearly see there is minus sign and here we have plus sign. Most of things are the same. So if I assume this as a sine theta plus cos theta, if I assume this as a, then it will become a minus 1 and this will become a plus 1, and instead of this one I can use a plus b into a minus b, and that will become a square minus b square. Okay, so let's suppose I'm taking sine theta plus cos theta as something else, whatever you can assume it. Let us suppose this is alpha, and so it will become alpha minus 1 and upon sine theta, and this will be alpha plus 1 upon cos theta. And similarly, we can recall an identity which is a plus b into a minus b. So I'll use that identity here. It will be a plus b into a minus b, that will be a square minus b square, and as a denominator we have sine theta multiplied by cos theta. Now simply I'll put the value of alpha from here, which I have already assumed, that is sine theta plus cos theta and its whole square, and here we have minus 1 because the square of 1 is 1, and as a denominator we have sine theta into cos theta. Now simply I'll solve this by opening this bracket. This is a plus b and whole square, so it will become a square plus b square plus 2ab, and here we have minus 1 and upon sine theta into cos theta. Okay, simply now you can see, and this is sine square theta plus cos square theta, it will become 1. So this will be 1 plus 2 sine theta cos theta minus 1 upon sine theta into cos theta. 1 will be cancelled. Okay, so here we will left with 2 sine theta cos theta upon sine theta into cos theta. This will be also cancelled and we'll get our answer 2, and this is the very thing we have to prove in right hand side, which is equal to right hand side. Okay, so it was the first question of 8th. Let's do second one, that is tan square theta plus cot square theta plus 2, and you have to prove this as sec square theta and cosec square theta. Very easy question. So we already know what we know. Instead of we have what we have to prove. This is tan and here we have sec. Okay, tan square, and here we have sec square, here we have cot square, and here we have cosec square. So whenever we encounter with a question like this, we know already a relation between tan and sec, which is the second identity. What is that? 1 plus tan square theta equal to sec square theta. Okay, and the third identity, 1 plus cot square theta equal to cosec square theta. So by help of these two identities, I'll solve this question by taking left hand side. You can also do it by your basics, like change these trigonometry ratio in sine and cos, so I'll get the same answer. But here I know a direct relation between tan and sec, and similarly cot and cosec, so I'll use that relation to find out this answer. Okay, so here we have tan theta and here we have 2. So what I will do, tan square theta plus cot square theta, instead of these two I will write down 1 plus 1. One of them will be used in this and this one will be used with a tan square, so I'll write it down 1 plus tan square theta. Similarly here we have 1 plus cot square theta. Instead of 1 plus tan square theta, I'll use second identity. The very first one is sine square theta plus cos square theta. Second one is this one. So instead of this one I'll use sec square theta, and at this place I'll use cosec square theta. Now we don't have to prove I mean we want to omit this sign, so there is nothing plus sign between sec square and cosec square. Okay, so I'll use sec square as 1 upon cos square theta, and this will become 1 upon sine square theta. Now simply I'll solve this. It will become sine square theta plus cos square theta upon cos square theta into sine square theta. You know, sine square plus cos square, that will become 1, and it will be 1 upon cos square theta and sine square theta. 1 upon cos square theta, that is sec square theta, and 1 upon sine square theta, that is a cosec square theta. So it was the very simple question, like harder in comparison of previous lectures, but we'll solve some more questions, and last lecture we'll do some really good questions. Okay, quality questions. So I would suggest you that please pause the video and try to solve it before me. Okay, otherwise if you keep watching the video without solving or without having a pen and notebook, that won't help you. Okay, because when we see the lecture we can get everything, like we get everything, but whenever we just have a pen and notebook and try to solve them, we won't get any idea how to solve that. Okay, so these are the methods which when you don't apply them, you won't learn anything from this video. So I would suggest take a pen and notebook, rough notebook. Okay, pause the video, see the question and try to solve it at your own. If then you don't know how to solve that, then please resume the video and see the video, and after watching the video all, try to solve all the questions. Okay, note down the questions and try to solve these at your own after watching this video. Okay, this will really help you, because until you do something for you, that is not gonna be helpful for you watching this video. Okay, so please I would suggest still take a pen and notebook and start solving the questions. Okay, next question, moving on. That is question number 9, and the very first question of 9th number, that is 4 power of cos A minus 2 power of cos A, and we have to prove this as 4 power of sin A minus 2 power of sin A. Now simply we can clearly observe it. We don't have to change anything in this, because we have basic identities like basic trigonometry ratios, which are cos and sine. Okay, by taking left hand side, these are very easy questions. By taking left hand side, which is cos raised to the power 4 minus cos raised to the power 2, I'll take cos square common from here. By taking cos square common from here we will left with cos square A minus 1. Getting my point? Okay, so I don't need any cos, so instead of cos I'll use 1 minus sine square A. So here I will use 1 minus sine square A. Similarly, instead of this one, this will become 1 minus a sine square a, and here we have minus 1. Minus 1 will be cancelled, so this will be 1 minus sine square a multiplied by, here we have multiplication, multiplied by minus sine square a. Okay, so this minus sine square a will be multiplied by 1, then it will become minus sine square a, and here we have minus and we also have minus. So whenever you encounter with two minus, okay, two minus signs, or in even number of minus sign, then it will become plus sign. Like you have minus sign as multiplication, like if you have odd number of minus signs, like only one minus sign, three minus sign, five minus signs, okay, that will give you minus sign as a result. But if you have minus sign as even number, okay, like you have minus sign two times, four times, six time, eight time in multiplication, okay, keep that point in multiplication, that should be in multiplication, so it will always give you a result of plus. Okay, so here we have minus and minus, two time minus, so it will be plus. Sine square a, sine square a, that will become 4 power of sine square a, and this is the similar thing we have to prove, and this is right hand side. Don't say we don't have minus sign first, no? So it will sine to the power 4 minus sine square a. Let's move to the next question. That is second question we have similarly 4 power of, okay, this is 4 power of sine a minus 4 power of cos a equal to, we have to sine square a minus cos square a equal to, we have to 2 sine square a minus 1 equal to 1 minus 2 sine square a. Now pause the video and solve it at your own. Okay, if you're able to do something, like I'm not suggesting that you will become master in trigonometry in one day, but similarly if you try a little bit, then it will really help you. Okay, so by taking left hand side, that is sine to the power 4 minus cos to the power 4. Now we can see this is square of square. I can write it down like this one, because power of power will be multiplied, so it will become sine to the power 4. So I can write it down like this one, and it will be sine square cos square a and its whole square. Now you can clearly see there is something in square minus something in square, so similarly it will become a square minus b square. Okay, this whole is a and this cos square is b, so this is a square minus b square. And instead of a square minus b square, I can use a plus b into a minus b. Okay, so by using this identity, I'll write it down like this one. This will be a plus b multiplied by a minus b. This will become 1, so 1 will be multiplied by this one, so it will be sine square a minus cos square a. Okay, this is the same quantity we have to prove. The first result we have reached. The second result, I don't need any cos square a, so instead of cos square a, I'll use it. Okay, so this is sine square a minus, instead of cos square a, because I don't need cos square a here. Okay, here we have only sine square a. Instead of cos square a, I'll write down 1 minus sine square a, and this will give the exact result which we wanted. There is minus sign, okay, before bracket, so all signs of quantities will be changed, so it will become minus, and this square will become plus. This sine square a plus sine square a, it will become 2 sine square a minus 1. Okay, this is the second result we have to prove. And the third result, we don't need any, sorry, here we have cos square a 1 minus 2 cos square a. This should be like this one. Yeah, this is like this. So in this formula, I don't need any sign, so instead of sign, I'll use it. Very good, 1 minus cos square a, and here we have cos square a, so this will become 2 cos square a, so it will become 1 minus 2 cos square a. Okay, this is the third result we had to prove. Now moving to the next question, which is sec to the power 4. Okay, second question we left by mistake. Second question is 4 power of cot a minus 1. We have to prove this is cosec to the power 4 minus 2 cosec square a. Okay, this is very easy question, don't panic. Okay, so this is power 4, so I will write it down like I break power 4 by taking power 2 and its whole power 2. Okay, similarly I'll write it down like this one. This will become cot square a and its whole square minus this will become 1 square, and I'll use the same identity which I have used here. This is a square minus b square. Similarly we have a square minus b square. Here I'll assume this as a. If you want to assume then you can do, but I don't need to, like, because I can assume this is a in my mind, so it will become a square minus b square, and I'll write it down like a plus b into a minus b. Okay, getting my point? So similarly this is the third identity. Okay, so it will become cosec square a. Instead of cot square a, what you can write down, this will become cosec square a minus 1. Okay, instead of cot square a I have written here cosec square a minus 1, and this minus 1 we have, so it will become cosec square a, and this will become cosec square a minus 2 multiplied by cosec square a, so it will become 4 power of cosec square, sorry, cosec minus this will become 2 cosec square a. Okay, this is the same result we have to prove right hand side. Let's move to the next question, which is question number 4 and last of question number 9, that is 4 power of sec a 4 power of sec a minus sec square a, and we have to prove this as 4 power of tan a plus tan square a. Similarly we will use the same method here as we have used in previous questions. Okay, by taking left hand sides, that will become sec to the power 4 minus sec squaring. What you can see and you can observe here, I can take sec square common from here, so I'll take sec square common, and instead of like this power 4, 2 power is taken, so we will left with 2 power of sec, and here we have taken sec square common, so we will left with only 1. Now you can clearly see I don't want sec square here, so instead of sec and tan I can use second identity, which is 1 plus tan square a instead of sec square a. Similarly I'll use 1 plus tan square a, and here we will have minus 1 will be cancelled, plus 1, so it will become 1 plus tan square a multiplied by tan square a. So simply I'll multiply it by this bracket, so it will become tan square a plus tan raised to the power 4 of a. Okay, this is the very result we have to prove in right hand side. Let's move to the next question, which is question number 10, and the very first question of 10 which we have. Now we can clearly observe we have done some around 30 to 40 questions in previous lectures, or these lectures are helping you. So moving to the next question, that is first question of 10, 1 plus sine theta and its whole square divided by 1 minus sine theta and its whole square divided by cos square a, and we have to prove this as 2 1 plus sine square theta upon 1 minus sine square theta. Now you can clearly observe it. First of all we'll solve this, and after solving you'll get to this point. This will become a plus b whole square, and it will be a square plus b square plus 2ab 2a into b. Similarly this bracket will be also opened by a minus b whole square, so it will become a square plus b square minus 2ab divided by cos square a. We don't have to change cos square a because in last step I'll use instead of cos square a I can write down 1 minus sin square a as a denominator. Okay, and this is the same quantity we have to prove. Okay, so this will become 2 sin theta and this is minus 2 sin theta, so it will be cancelled. Okay, 1 square plus 1 square, so it will be 2 sin square, it will be 2 sin square theta. Instead of cos square theta I can use 1 minus sin square theta. Taking 2 common from here, I left with 1 plus sin square theta in bracket, and this will give us 1 minus sin theta. Okay, and this is the same quantity we have to prove. So it was question number first of 10th. Let's move to the next question, that is question number second. Okay, and that is sin cube theta plus cos cube theta upon sin theta plus cos theta plus sin theta cos theta equal to 1. I have told you 5 identities to remember, and I hope you remember those identities. So I'll use those identities here, one of those, and that is a cube plus b cube. So this is sin cube plus cos cube theta divided by sin theta plus cos theta. This is left hand side. Okay, we don't have any tan, cot and any other ratios, so we don't have to convert anything. These we already have sin theta and cos theta. Okay, so you know a cube plus b cube. What is a cube plus b cube? That is a plus b, a square plus b square minus ab. Okay, so I'll use this identity in this one. So instead of a I have sin, instead of b I have cos, so it will become a plus b, a square plus b square minus ab divided by sin theta plus cos theta, and later we have sin theta multiplied by cos theta. So sin theta plus cos theta will be cancelled, and instead of sin square theta plus cos square theta I'll use 1 minus sin theta cos theta. Okay, and last of question we have, so this one will be also cancelled and we'll left with 1, and this is the exact thing we have to prove. This was the question number second, and moving to the next question, we don't have any next question, so let's move to question number 11. The very first question of 11, that is tan square a minus tan square b, and you have to prove this as cos square b minus cos square a upon cos square b into cos square a. Okay, this is very easy question, and instead of this one, sin square a minus sin square b upon cos square a cos square b. First of all I'll take this one. Okay, I'll reach to this conclusion, and later on I'll solve this one and you'll use this one to prove the third step. So by taking left hand side I have tan square. Now you can clearly see there is a cos square, and cos square is the opposite of sec square, and I know direct relation between tan square and sec square. So instead of this tan square I can use sec square a minus 1. Similarly this will be sec square a sec square b minus 1. So this will sec square a minus 1, and we have minus sign outside of this bracket, so all signs of quantities will be changed. So it will become minus sec square b, and it will become plus 1. Plus 1 will be cancelled, and we will left with sec square a minus sec square b. Instead of sec square a I'll use 1 upon cos square a minus this will become 1 upon cos square b. Okay, now you can clearly see this is the same quantity we have to prove, and it will become cos square b minus cos square a upon cos square b and cos square a. Okay, so this is the same quantity we have to prove. This is the very first result, and for second result I don't need any cos here. I need sine. Okay, and as a denominator we have same quantity, so we don't have to change denominator. Let it be the same as we have. This is cos square b and cos square a. Instead of this cos square a, I can use 1 minus a sine square a, sine square b. Similarly, at the place of cos square a, I can use 1 minus sine square a. Okay, and simply by solving you'll get your result. This is 1 minus sine square b, and I have minus sign, okay, before the bracket, so all signs of quantities will be changed. This will become minus 1 and it will become plus a sine square a, upon we have same quantity cos square b and cos square a. This one will be cancelled and I'll left with a sine square a minus sine square b upon cos square a cos square b. This is the second result we have to prove. Okay, hope you are getting my points. And the third, sorry, no third, second we have sin a minus sin b upon cos a plus cos b plus cos a minus cos b upon sin a plus sin b, and you have to prove this as a 0. Okay, so by taking left hand side, simply you can observe there we have to bring 0. So by taking left hand side and solving this, I'll get 0. Okay, so this will be multiplied by this one, so this is a minus b and this is a plus b, so it will become a square minus b square. Getting my point? I'm just solving this one. Okay, and we have earlier like learned that how to solve this one. This will multiply by this one, and this is what we can see here. This is a minus b and this is a plus b. Okay, instead of a we have sin a, instead of b we have minus sin b. Okay, so it will become a square minus b square. Similarly, we have same quantity here, cos a plus cos b, and here we have cos a minus cos b. So I'll use the same identity, a plus b into a minus b, so it will also become cos square a minus cos square b upon these both of quantities will be multiplied, so it will be cos a plus cos b multiplied by sin a plus sin b. This sin square a plus cos square a, it will become 1. Okay, and this will become minus a sin square b minus a cos square b upon we have same quantity, so I'm not writing it down. By taking minus sign from common, by taking minus sign common from here, so it will become sin square b plus cos square b, and we have same quantity, so it will also become 1. So 1 minus 1 and similar quantity, that will become 0, and this is the very quantity we have to prove. Okay, let's move on to the next question. That is very interesting and very like now we are doing some quality questions, and after this lecture you will see some sort of hard or tougher questions which can be sometime asked in CBSE exams. In RBSE exam there is no chance of asking these type of questions because we have like some similar type sort syllabus, but in CBSE they can ask anything. Okay, so this is question number, I should take another page. Question number 12. You are given with some values x equal to a sine theta, y equal to b tan theta, and you have to prove a square upon x square minus b square upon y square, that is equal to 1. Okay, so let's solve this one. Now we have a square here and we have x square here, so by squaring, let us suppose this is equation 1 and 2, so squaring both equations, squaring equation 1 and 2, if I square this equation then it will become x square equal to a square sin square theta. Getting my point? And I have to take a square upon x square, So instead of x square, I'll use a square sine square theta. Okay, similarly we'll use here square. I'll square this one, so it will become y square b square and tan square theta. Okay, now by taking left hand side we have a square upon x square minus b square upon y square. So it will become a square. Instead of x square, I'll use this one. So this is a square sine square theta minus b square upon, instead of y square, I'll use this one. So it will become b square tan square theta. A square will be cancelled, this will also cancelled, and we will left with 1 upon sine square theta minus 1 upon tan square theta. Now we clearly know 1 upon sine square theta, that is cosec square theta, minus this will become cot square theta, because 1 upon tan is cot, and instead of this cosec I'll use 1 plus cot square theta. Okay, minus this is cot square will be cancelled, and we will left with 1. This is the same quantity we have to prove. Okay, so this was a little bit different question. So these type of question may be asked in the exam. Okay, let's move to the next question. That is question number 13, and this is the similar question. I hope you will do it. X equal to r sin a cos c, y equal to r sin a sin c, and z we have r cos a, and you have to prove r square equal to x square plus y square plus z square. Okay, by taking any side of this one, so I'll use this side by taking right hand side, and I'll show this is equal to r square. Okay, these are very easy questions. Okay, so first of all I'll use x square. So by squaring both all three's values, so the very first is x square, second one is y square, and z square. So instead of x, I'll use r sin a cos c, it's all square. Instead of y, I'll use r sin a sin c, and it's all square. And the very last quantity, which is r cos a, and it's all square. This will become r square a sin square a cos square c. This will become r square sin square a sin square c, and it will become r square cos square a. Okay, now you can clearly see from here, I'll take r square sin square common. Okay, and by taking common from here, I'll left with cos square c plus sin square c. Here we have r square cos square a, and okay, this will become 1 because sin square theta plus cos square theta is 1. So this is r square sin square a plus r square cos square a, and similarly I'll take r square common from here, so it will become sin square a plus cos square a, and this will become again 1. So we will left with only r square. This is the 13 number question. Okay, so these were some questions we have gone through, and let's do last question. And in next lecture, I don't know how many lectures will be there, but this series will definitely help you understand the basics of trigonometry ratio. So trigonometry identity. 14 number question we are doing, that is a cos theta plus b sin theta. This is given as m, and a sin theta minus b cos theta, this is n, and you have to prove a square plus b square equal to m square plus n square. Okay, very easy question this is also. So by taking right hand side, we have m square plus n square. So I'll use the value of m and n from this one. So instead of am, I'll use a cos theta plus b sin theta, and it's all square. And instead of this one, I'll use a sin theta minus b cos theta, and it's a whole square. So I'll open this bracket by using a plus b in whole square. This will become a cos a square plus b square plus 2 a b. Okay, similarly I'll open this bracket by using a minus b whole square. It will become a square plus b square minus 2 a b. Okay, now solve this further. This will become a square cos square theta plus b square sin square theta. This will become 2ab cos theta sin theta, and here we will have a square sin square theta plus b square cos square theta minus 2ab cos theta sin theta. Yeah, now you can clearly see this will be cancelled. Okay, and by taking a square common from here, we will left with cos square theta plus sin square theta. By taking b square from common from here, so we will left with sin square theta plus cos square theta. It will become 1. This will also become 1, so this will become a square into 1 and b square into 1. This will be a square plus b square. Okay, so please like, comment and subscribe the channel and share it with your friends who are in 10th class or your classmates. Hope this lecture was helpful for you. Okay, and be connected. See you tomorrow at the same time. Till then, take care, and please let me know how was the lecture by commenting in comment section. Okay, see you.